Hey everyone, welcome to our talk about change data capture. Let me introduce ourselves. My name is Dima. I'm formerly a systems and networking engineer for a lot of time. And last year I joined the IPTF team as a backend developer. I've been working for Wix for 4 years now.
Hi, I'm Avi. I'm working as a principal infrastructure engineer at the Server Guild. In my everyday life, I do my best in turning hops into ops, and I've been working for Wix for the past 3 years now.
Okay, and we came today to talk about a project we've been working on for almost a year. It's a project called Change Data Capture, or CDC. It's not the same CDC as you know from the COVID period, but something more technological and less diseaseful. So we'll go through the agenda. So we'll start with a brief introduction so everybody knows what's change data capture in the technological world. Then we'll go through some use cases where you can use it in your day-to-day jobs or potentially in the future, if not now. Then we'll see how we actually achieve it in Wix. So we use it today at Wix. You will see how it works in production. So that's really exciting. That's what we mainly focused on this year to get this delivered to you. And then at the end, we'll leave some time for questions. So anything you want to ask us, if we won't know it, we'll just either lie to you or postpone it to later. So let's start with looking at CDC itself. So CDC, or Change Data Capture, is a very simple concept. You track changes on your data, and based on these changes, you can take actions. And actions can vary depending on what you need. So let's take a look at an example. This is a basic SQL insert statement, adding some entry to our database. So we insert here Elon Musk, age 50, from the United States. This can be easily represented as a simple JSON. So before, we had nothing. We had a null. And now, we have a new row. Okay, Elon Musk, age 50, from the United States. Now, let's take a look at a more interesting example. So you might know this random guy, Debezium, right? So we set the country of Debezium to be Ukraine. So this change can also be described simply. So now, Debezium after the change is in Ukraine. Of course, he's 21, as you all know and love him.
This guy never ages.
Never ages. So that's the idea of tracking changes. But OK, that's pretty theoretical. How this works? So it all starts with a MySQL database. In this case, we focus on MySQL. So something happens. It can be an insert, can be an update, or it can be a delete of some data. Next, there's a thing that's called a binary log or a bin log. A bin log is a log of all the transactions that happen in the database in the same order which they are committed. And it's kept internally on the same server. Okay? Next, we have something that's called a connector. A connector is something that reads the bin log, and for each change that happened in the log file, it produces a message to Kafka. And the connector, in our case, is based on some open source product called Debezium. And everything that happens will be produced. So that's what's described here as well. So the binary log is the log of all of the operations that happened in the same order which they are committed, and it includes all the change operations. So you may wonder, OK, that's pretty, OK, some nice piece of information, but how can we use it? How can we solve problems with it? So what do you think, Avi? So we brought a really smart guy to tell us about it.
I wonder where it is, but I tried to do it. So let's examine some backend code that most of you either wrote or thought about, whether you've been working in Wix or previous company. You have an app, and as Dima said, every starts with MySQL database. So your app getting a request, it handles it, it writes something to MySQL, and then the product guy says, we also need to index it in Elasticsearch, and maybe we need some cache operations. So in a naive way, what you're doing is basically adding to your code a statement which do the search index, or adding yet another statement, synchronous statement with update Redis, right? So let's see kind of problems that we have with it. OK, let's examine some potential issues we might have with it. So first one is atomicity, right? None of these paradigms can be in an all or nothing behavior, right? We cannot have a transaction between writing to MySQL, Redis, Elasticsearch, or yet any other collaborator that we have. So we are dealing with the fact that we won't have atomicity. Second thing is harder retries, right? We are now working with 3 collaborators. We don't know what happened if, let's say, we manage to write something to MySQL. Afterwards, we try to write to Elastic. Everything works amazing. Then we try to update our caching layer, and it fails. So we can say, that's no problem. I'll just write a retry in my code. Yeah, but the retries are limited, right? You cannot retry forever. The request will drop, whether the HTTP handler will drop or the gRPC request, which was just dropped. So retries, let's call them really limited, challenging, and in addition, it's not code that you want all over your technology stack.
Yeah.
Another thing is by writing that kind of code, we are increasing the request latency. So if we started with an app that just writes to MySQL and latency was, let's say, X, after it will do its additional round trips, in our case, 2 additional round trips, so obviously our server will react slower, and the one that will suffer it is basically a user, right? The 2 next things we're going to talk about disadvantages in this kind of approach are bulk inserts, deletes, and race condition. But before we continue on, some of you will also see this architecture and say, like, OK, I can change it. I can save something to MySQL, and instead immediately go to Elastic and Redis, I will just publish a message to Kafka. And handlers of this message will do the Elastic and Redis stuff, but it still won't do it, because we cannot have atomicity between MySQL and Kafka, and we cannot have retries if we manage to save to MySQL, but fail in producing message to Kafka. So it basically ends up the same thing, maybe a reduction of the problem, but no big solution around that. So let's move on and talk about bulk actions. So I'm sure most of you used or will use in the future databases like MySQL or MongoDB. So whether it's relational database or non-relational database, you all know that kind of problem, right? Let's see the SQL statement. Delete from orders where customer ID equals some sort of a GUID, right? So when we are running that kind of stuff in MySQL or in Mongo, what we will get is only the amount of rows that got changed. So in that matter, we just deleted 10 orders of a given customer, right? So if we want to maintain Elasticsearch index or we want to maintain some Redis cache, it's really hard to maintain those because we don't know which orders got changed or which order got deleted. So our cache essentially will be invalid. Same goes for our Elasticsearch index or for anything else we're going to do. And it happens the same if we're going to do updates. So this is another problem that we cannot currently solve. And this is kind of a minor operation that most of us doing in our everyday development when we're working with databases.
OK, but what about race conditions? You promised something about that?
So in the end of the day, it's a lecture about programming. We have to talk about race conditions because people have to,
we really
respect
have to,
us.
and
so,
we prepared the slide for it. So
yeah, so we have some problems with race conditions.
So are you ready for this? This is a good one.
I think I am.
Yeah. So we have an application that is doing the dual writes. So it first writes to MySQL, and then it updates the search index. OK? So let's see what can go wrong in theory. So we have a request. The request is just setting an entity to the value of A. OK? So it saves it to the database. The value in the database is A. Everything is awesome. But we have another request coming in flight. And it sets the entity to the value of B. OK? So now the value of the database is B. Now, because application that process request 1 is a bit slower than application that process request 2, what happens? Request 2 already update the search index. It already has the value of B. So once finally the instance that process request 1 handles the request, it will set the value to A. This causes a mismatch. So in the search index, eventually we'll have the value of A, but in MySQL, we'll have the value of B, which cause some problems for us, of course. Thanks. So that's very theoretical, but it could happen.
Yeah, OK. So let's think about that. So we talked about this paradigm of writing to MySQL and then Redis, Elastic, or whatever, or maybe trying to just write to MySQL and produce to Kafka and handles it. So we all agree that this is like basic code that we're doing in the everyday life, but we are all seeing its flaws and disadvantages. So once we are talking about the CDC approach, let's see how we can solve those kind of stuff. So let's see how the same app will look with the streaming approach. So Yet again, our application writes to MySQL, and then imagine that. The only thing our backend code does is actually saving to MySQL. That's it, no side effects. Our CDC infrastructure will take the change from the database, from the bin log. Dima reminded us before what it is. So a message will be produced with the change. So we got that down. It will be atomic. We know that if something went into the database, imagine that. Something went into the database, and you know for a fact that infrastructure got your back and will produce a message that reflects the exact change you did in your database. For sure, 100% guarantee. So then the only thing you got left is write a consumer or multiple consumers that actually persist stuff to Redis or maintain your index. So when we think about that, let's think about the stuff that disadvantage. We talked in the previous approach that you can see on the left, right? Or on your right, your left, sorry. So we talked about atomicity, that we cannot have all or nothing behavior, right? So atomicity now, you know for a fact something went in a database, it will get produced as a message. Second thing about retries. So now retries are way easier, right? Because we are just using Kafka retries. We save something to MySQL, we know the message went off and produced, so our Redis consumer will have the better retries, our Elasticsearch will have better retries, and we didn't write code about it because we have ground, right? So just marking ground retries and we got it. Let's see our server performance right now. The only thing our server does is basically write to MySQL. No write and then produce message, no write and then maintain a cache, it just write to MySQL. So our users will benefit even a better performance time. Another thing we talked about is bulk updates. So we talked about bulk updates and us not knowing the exact rows that got changed. So now we know it. Because we are attaching ourselves to the bin log, let's say update where I did, statement of update where updated like 100 records, I will get 100 messages. One message for every row that got changed. And about the race conditions that Dima is constantly worried about.
Yeah, it's less probable now.
Yeah, trust me, I work with him a lot.
Yeah.
So the race conditions are all solved. Why they are all solved? Because basically, we are producing the messages in the exact same order they got into the database. So we know for a fact our message will be ordered in the way things actually happen in reality.
Okay. So how can we use it? Like, what are
So
the actual use cases?
A lot of you thinking about now, this looks kind of fancy. We do write code, this kind of stuff in our everyday life. This sounds pretty nice. What can I actually do with it? So let us try help you with it. So a really common scenario that you can use this kind of infrastructure is basically maintaining a cache, maintaining a search index, or maintaining any other materialized view, whether it's in MySQL, MongoDB, or any kind of another thing, like yet another system, etc. Another use case is data migration between databases. I mean, data migration is a big topic in Wix, in the software industry as well. It isn't a big fun. But imagine that you can stream everything that happens in the database. This can open a huge door for you for doing migrations. Another thing is data migration within the same databases. So when people say migration, they always think about, I want to move something from A to B, right? But it's not really the case. Each and one of you that work on the same system for a few years know that you have a lot of migration within the same databases, which means essentially that the source database and the destination database are the same one. And you just need to move some internal stuff or internal representation of things. Producing event from event store. So event store is a big thing, but don't worry, we won't get to it in this lecture. But I know some of you tried this model in the past. So when you're working with event sourcing, you're using event store. And when you're using event store, every change that happens in your application, you commit it to the event store, and then you want to make sure every change, every event that you got committed to your event store being produced to Kafka. And the last thing for you BI people or people who are doing analytics on the system, I'm sure a lot of you in the past wrote an ETL procedure, which run periodically, let's like once a day, once a week, and query the entire database with super heavy queries, and then create a view. Wouldn't it be better to just stream real-time the changes and then build your view on the fly instead of doing these crazy queries? The DBA call you at night and say, stop, you're wasting our money and time.
Okay. So I think enough like theoretical stuff. Let's look at the real thing. Like let's look at the demo
We can
What
do
do you
that.
think?
We can do that.
Yeah. Let's see how it works. Let's see how it works.
So our first demo for this lecture will actually illustrate the thing we just saw you. So we're going to show you a live implementation of data being inserted to MySQL and via our infrastructure being communicated to Kafka, and then we're going to have a Kafka consumer which will populate a distributed cache. In our case, I've used Redis. So our idea is the database will constantly, the cache layer will constantly reflect the data we have in the database. So let's try and see it. So what we're going to see here is basically I'm going to run a test. This is the entire application I have. As you can see, it's going to be a Kafka consumer, a really, really thin one. It's a dedicated microservice that hosts only that. It's a consumer. And as you can see here, the only thing that you, as a developer, will have to implement, by the way, it's a Nile service, so move for Nile. The only thing that the developer will have to implement is handle create message, which essentially will be the code that will have to deal with a database change, which is a create. He provides also handle delete message and provide handle update message. So this is the only code this microservice basically hosts. So as you can see, really thin code. I have a Redis client which can set stuff. At that point, I can tell you that as you can see on the right side of the screen, I have a shell which we constantly open through this video. And I have two screens there. One shows every message that got to Kafka and wired to the Kafka that my test environment bootstrapped. And the other one will be Redis, where I actually run a JavaScript script, and I just fetch every data from Redis. So it would be easier to illustrate what we're doing here. So right now, I created the procedure in our test kit. This test kit will be available to your application at any given time. I created the user. User ID is 1, name John, lives in New York. So as you can see, like Dima showed us before, the JSON of the before-after. So this is exactly a message being produced. This is the actual Kafka message that got produced due to the fact I created a user in my test environment. So we can see the source, we can see the name, we can see the before column is null, right above there, and after is exactly what I inserted. So I'm creating now yet 3 more users. And as you can see, 2 users here are Dima and Avi, and their address is TLV. Pay attention to it, we're going to talk about it soon. So as you can see, the operation is create. I will create users. Okay, messages being produced for every user I'm creating. Okay. Okay, so our Redis client kicks in. Let's see. Basically, we have even if you see the JSON being produced, you even get this JSON serialized by our infrastructure, so you don't have to mess with raw JSON. You have the entire content serialized, and the only code that the developer provides, the backend engineer, is the code that maintains Redis, right? So I'm doing a set, I'm setting the ID, and I'm saving stuff when I'm serializing them, as you can see, to JSON. Pretty easy. Yes, wait. Only took half a year to develop, man. So basically, yeah, we can skip those. I'm getting messages for every user, right? Because I created all of them. So now let's fetch data from Redis. I'm going to write the fetch Redis data script I have. And there you go. I have 4 users that have the exact same thing I have in the database. So right now, our cache layer and our database layer represent the exact same kind of data. Now let's look at something on MySQL. Remember when we talked about batch updates before, right? We talked about what happened that we update multiple, we set an update where statement, and on this update where statement, I'm actually updating users. It's pretty hard to see, but I'm updating users where address is Tel Aviv, where address TLV, I'm going to change it to Tel Aviv. Now, if you remember, I created me and Dima in TLV, and then the product guy comes in to the room and said, like, remember I said Tel Aviv will be TLV? Okay, I want to change it. I want to call it Tel Aviv from now. So I'm changing the address. This will affect only 2 records out of the 4 I inserted to the database. So pay attention to that. So my handler kicks in, the handle updated message kicks in right now, and I got 2 messages. So remember when we told you before, update where you don't know which stuff got updated. So here you go, 2 messages that got updated, and here I can see even the exact before and after stuff. So in the before, I can see Avi, TLV. In the after, I'm getting name Avi and address TLV. It's really important to also notice that the before and after includes the entire entity and not the only part that got updated. So it's pretty easy when you do materialized view and all kind of stuff. So let's just handle the updates. Let's fetch the data from Redis. And then we can see in the data, Tel Aviv and Tel Aviv. So once again, our database is constantly being the same as the cache. The cache is being the same as the database. I'm doing a selection from the database, same information. Now think about our server engineer that writes the code. The server engineer only committed changes to MySQL. He doesn't know about Redis. Only the consumer knows about it. The message, even the engineer who wrote the server code, didn't produce the message to Kafka. He just saved the data to MySQL. 0 side effects. Now let's run something that I don't recommend any of you to run in production, which is basically delete the entire table, right? So delete the entire table. Again, let's say I'm doing it on MySQL, I will get, okay. But now I get 4 messages for every entity that got changed. So I'm getting the stuff. As you can see, again, the content is already serialized. You don't have to do anything. You're getting everything from the infrastructure. And you're getting a delete. You're going to get 4 different messages, one for one. I will just remove the breakpoint. And let's see Kafka again. We look into Kafka. Again, we can see the operation is delete. We can see the after is null, because the after we just deleted something. And we can see the last state of the entity. Let's fetch data from Redis, and you guessed it right, empty. So once again, database is with the cache. Let's see it, and just query from database. Obviously, you can guess it's going to be empty. By the way, this is the part where you applaud. And this is the part where I actually close my video.
Yeah, pause it. Pause this video. Okay. So very cool. So
I know, right?
yeah. I expected a bit more applause than this, but
yeah,
it's fine.
tough crowd, man.
A tough crowd. It was hard to do.
Why?
We'll get to it just now. So you ask yourself, okay, changes are pretty nice, but I have tons of historical data and databases that I already have, I don't know, terabytes of information I want to use. So what can we do with this data? Can we actually also stream it?
I don't know. I don't work for premium. I don't have this kind of data already.
You don't? Didn't you save some? I hope not. So, okay, we can also stream existing data from your database using the connectors or CDC. This is called a snapshot. What a snapshot does, it selects the current existing rows of your database, and for each existing row, it would handle it as if it was a create statement, and it streams it as a message to Kafka. This is very useful for database migrations. So for example, let's say you want to take all of your database and move it to some other database, or maybe transform it and save it to the same database. So that gives you the ability to work with the existing data and not only the changes. Also, you can combine it with changes later, okay? So if you want to just export it and process changes afterwards, you can combine it with the streaming approach of the bin-log. Or you can use it independently. So these are the options we have with this feature. So let's take a look at another example, and this is from production, which is really nice to see, of using the snapshot feature to migrate the database. So what we're going to do here, we have a MySQL table that has a very basic schema. This basic schema, has an ID, a full name, a first name, and a last name. The first name and last name are new fields we got from our product that we need to populate, okay? Because we need to personalize just the first name of the message. So let's see what happens. So we have a MySQL database, and we have a connector that will stream our changes or snapshot, sorry, to Kafka. And then we have a consumer we prepared that will consume every message, transform it, and write it back to the same table. This is a migration within the same database that we'll see right now. We'll see later how the consumer was built. So first, let's see the state. So first, as you can see, we have a table that has IDs. It has the full names, and no first name and no last name for anyone. And the schema is on the right side. It's kind of small, but I hope you can see it. We have the consumer running in the background, but now we'll just show how we create the connector itself. So to create the connector, we wrote a service. It's called the CDC admin or the CDC administrator. It allows you to connect to your production database and stream information out of it to Kafka. You specify the name, you specify the database coordinates, and you specify your artifact. What happens next is it will give you the topic which will it stream the data to. Of course, you don't really have to know this topic because our infrastructure just lets you specify the same parameters on the consumer side, and we will discover the topic name for you. So all you have to do, you will see soon, we'll take the topic name, just to show you how a message looks like for real. And this is production, which is really nice. We'll go to Confluent, and we prepare the topic name ahead of time so we can see it in the messages. Just a moment. Refreshing. It's obviously the second one. It's always the second one. Okay. Partition 0. Okay. Now let's take a look at the message. So it's very, sorry. No. Wait, I can salvage it. Okay, so let's take a look at the message. It's very similar to what you saw in IntelliJ before. Yeah, obviously. Even videos can go wrong, as you can see. So before we had nothing. This is if it was a create. You see, before it's a null. Then we have Ann Miller, I guess. And no first name, no last name. Also, you can see there is a Boolean. Snapshot is true. This means this came from a snapshot. This is not actually a change, but it is actually from your current state of your database. So let's see what happens next. So now some time passes. Okay. Let's take a look at our table. Let's see if we have all the data populated. So pretty nice. We wrote a consumer without bugs. And this is our production, which is pretty cool. Very nice. So you probably imagine, like, OK, you kind of hid from us all of the code you wrote, all the consumer part, which must have taken you, I don't know, like weeks to develop, to actually write this migration, right?
The struggle is real.
Yeah. Yeah. But no, I think it's much more simpler than that, and we'll show you how we did it and how you can do it yourself later. So it all starts with a very nice feature from Framework. It's called the generator. A generator has templates you can use. You saw some template earlier in the previous lecture from Loom Prime. So this is a special template just meant for CDC. We have other templates meant for CDC for SDL, if you're interested. But in this example, it's a kind of free schema. So it provides you a basic scaffold for your service with tests, with a migration function placeholder, and with the service itself that will initiate the consumer with the same parameters you will create a connector for later. Next, all you have to focus on, which is the heart of the migration, in this case, is the migration function. The migration function, in this case, we admit it's really, really simple, yeah? It's actually a very idiotic example of just splitting string, but it can do anything here. You could imagine any code you could do. And this can like make RPC calls, take data from some external sources, doesn't matter. Essentially here, it's very simple. You update by ID, and you set the first and the last name for the values based on the full name. So very simple. And we know migrations are very sensitive to people, and people want them to work, and they want them to really have confidence. When you perform the migration, it will really work in your production environment, and you don't like, yeah, it's nice, but it will fail. So for that, we have a great test kit. And we use it as part of the template itself, and here you can see an example of it. So here, this is the test for migration, which in this case is also a simple test. We insert a user to the database. In this case, it's Nicolas Cage, because everybody likes that guy. And we expect him to be eventually populated with Nicolas and Cage as the first and the last name. And that's what we want to test. And as exactly in production, we created the connector and streamed the information from the database, we also do it here behind the scenes. You see this method of create connector or create eager migration connector. This does this. Like there is in the background the entire flow. There is a Kafka, there is MySQL, there is a connector. Everything happens for you in the test. And eventually, because it's asynchronous, you expect it to be the user. And that's the test. So that's very simple. Like that's what we had to do here. The next part is actually, because it's in production, we have to bind it to the database. We have to drink some coffee, of course, because we are addicted. And we have to GA and stuff. So we do that. And afterwards, we want to monitor it. So for monitoring, we also use standard tools. Forget about it.
Not that fast.
Not that fast. So we have to stream the data to do the migration.
Yeah.
Damn it. So we stream the data. So create the connector the same way you saw in the video. It's not fake. It's like using the File Console UI, advanced UI. And we monitor it finally. So you can monitor the producer side and the consumer side. You can see the producer side on the left, which is the connector that produces the messages. And your artifact, which is a regular consumer, you can see the migration delay, the Kafka lag. And that's all we had to do to achieve this migration. And I think this is really exciting. I mean, this is what we worked so hard to achieve. And you can use it today, obviously. And there's also, not only that, not only you can use it, you have an amazing README. You can get at this URL. There's a Slack channel. There's an entire team maintaining this project. And hopefully more use cases will come in the future. And we really expect this system to take hold and really maybe start using these concepts to, I don't know, to populate your caches or to use these actual use cases in real life. Yeah. So that's what we wanted to show you. So I think we covered everything besides the questions part.
No, I
guess no questions,
right? I can see people from Econ waiting to maybe ask them questions, so I can see them. So basically, thank you for attending, and we would love to hear questions from you regarding everything that you just saw you.
Yeah, thank you.
Good. Yeah. Yeah.
Microphone.
Hi. Thank you for the talk. I have a question about the migration. If it's a long migration that takes a long time, do I have any way to see the
yeah, so
progress?
You have, it's kind of tricky, but you have the way to see you still produce messages, but your snapshot is not finished. And there is a way to see your lag of the consumer. There is a feature being developed to actually notify you when it ends. On Slack, yeah. But right now, it's kind of like, it's documented how to do it. You have to do it in a two-step process because it's asynchronous. You produce everything. You see the snapshot finish. And only then, you can see when your lag is 0, your migration ended.
I can add to that even in the service that we just saw, the CDC admin, which is, so you can say that this is my migration, and you can see the delay your consumer group has on this migration. So you can see if you produced all the messages, and then you can see how your lag, how much behind in consuming them. So you can totally monitor again. You got this Grafana views and the API already done.
Yeah, and for more advanced users, we also have logs, which count the number of rows being produced. But that's very harder to get to. But it's there, believe us.
And essentially, if you're going to think about the talk, like a lot of people will use it for migration, but we are aiming the future that a lot of people will use it not only for migration, it's to actually stream stuff that happen in the database and react in building views or even sending users that emails, that sending email when order got updated or something.
Yes, microphone. Oh.
Hi.
Hey.
Will you support showing only partial views of the data that's changed if like rows are like super heavy and the schemas are...
So we thought about it at first. First of all,
we do support it.
First, we can support it. We can not seeing everything. The fact that the default is showing everything, because most people, when they build views, sometimes they don't want to actually calculate the updates and say, like, I want to update only that field or that field. They say, like, give me the object currently. I want the object as it's now, and then just save it, so they use it. But if you have, like, a large column, some people have huge blobs. And they say, like, I want to stream it, but I have this column which has, like, 20 megabytes for every row. I want to exclude it. So once you create the connector in the service that creates the connector, and it says, like, this column I want to exclude, won't be streamed to Kafka.
Yeah, you can do both ways. You can include, like if you want some columns, or you can exclude. Both are supported. You can use it already today in the API. It's already supported by the API today.
Cool. I have one in the back and one here. He gets closer, he won for that, I guess. But we will get you, I promise.
Yeah, hi. Many times we have migrations that causes DB lags. So we have to reduce the speed. Is there a way to do it?
Yeah, this is a...
So definitely the thing is, you have, I guess most of you think about in the lecture, maybe thought about the word immigrator. Said like, we used that, it kind of worked, it's kind of okay, I combine it with quicks, I'm able to survive, but think about that. Now, you don't need to control the producer rate, right? You just produce messages. So you say like, if I will consume too fast, I will create a lag on my database, right? This is what you're saying. So if you noticed, we wrote the migration function. We did a microservice because we have Nile now, right? So it was easy to spawn a new service. We created the service with the migration function, and imagine that we deployed it, we GA'd it, right? So you can control the amount of deployed instances of the service. You can also control the amount of the partitions in the topic. When you created this migration in the administrator service, you can say, like, I want to stream that database, and I want this amount of partitions. And then you can control the amount of consumers you have in parallelism level. So you can set the phase of the migration. Yeah, it means that you need to see you don't have a lag, but definitely you could control it. We had a migration recently when someone had like 25 pods and reduced it to 20 and then spawned it to 30. So definitely we control it, just like any other Kafka.
And also the batch size. You can also, it's since you're using Greyhound in the background, it's Greyhound batch consumer, you can also set the batch size, play with it. And I guess did we cover? Oh, and there's more parameters you can later change, which probably. I'll replay for everyone. So the team will try to auto-scale the migration consumers based on metrics.
Yeah, I mean, because basically we have the...
We'll do.
And we will, for sure we'll have it because we basically have the metrics. We'll do the same thing you're going to do. Any Itai will come for a guild, we can do it eventually because he offered the feature. So obviously Itai will do it. So the guy on the back, which will be the last.
Hi. Two questions. What about access control? And the second one, how did you make sure that the messages from the binlong are written at least once or exactly once?
So for access control, right now there is limitation. We're waiting for we're waiting for a feature that will implement that will allow mapping the database resources to developers, not using the code ownership. For now, we have only pre-authorized admins that can create connectors. And basically, you write the consumer, and then you contact the pre-authorized admins, and they created the connector for you, as you saw in this video. What was the second question, sorry?
How did you make sure that the messages from the binlong are written at least once?
So there is every migration consumer should be able to handle the message twice. There is no exactly once guarantee.
The CDC stack, in general, by the way, every CDC stack out there, every CDC project, you have the guarantee of at least once messaging. Because if our system broke and then it got up again, it needs to fetch the stuff.
There are certain cases, the message will be processed twice, so you have to like, you know that word.
Your consumer code should be idempotent in the way that you can hand it once.
Anybody can say this word, nobody can say it.
But by the way, I recommend all of you for every
Whatever.
consumer you write to be idempotent, not only consumer for this stack, because I
Avi
have
knows
to
the
mention
word.
this sentence all the time. But
Yeah, I hate
Yeah.
this word.
yeah, so I guess that's it. Thank you for coming and ask us questions. And thank you.